In this tutorial, we will show you how to use Quick Easy IR Seeker with LEGO Spike Prime. Quick Easy IR Seeker requires the Quick Easy expander board for communication with the Spike Prime hub. To set up the hardware, first stack the IR Seeker board on top of the expander. It does not matter whether the head of the IR Seeker robot cover is pointing up or down. After that, simply use the provided cable to connect the expander to your Spike Prime hub. Be sure to make note of the port you are using. In our case, we use port C. When there is only one Quick Easy IR Seeker board attached, it can detect the IR ball in front with 180 degrees of coverage. The sensor can detect the IR ball's direction with 9 units of precision as illustrated here. For this 180-degree coverage setup, the direction is returned as color sensor reflection value, and the signal strength is returned as color sensor raw red value to your Spike Prime program. Let's start doing some programming. As soon as you connect your Spike app to your hub, you should notice that the Quick Easy expander connected to your hub is appearing as a color sensor on the port for which it is plugged into. Now, click the hub icon to see more details about the color sensor. Make sure you are displaying the reflect value of the color sensor, which represents the direction of your IR ball from the sensor. Turn on your IR ball and move it around the IR Seeker. You will see that reflect value changes. If you are running the legacy Spike app 2, the reflect value displayed should range from 1 to 9 representing the 9 directions. If you are running the new Spike app 3, all numbers are multiplied by 4, thus the reflect value should range from 4 to 36. Now, let's start making our first word block program that uses the IR Seeker. We want our program to display the direction value on the LED matrix on your hub. The value should be a single-digit number from 0 to 9. The IR Seeker returns a value of 0 when no IR ball is detected. First, we will create a variable for the direction. Then, we will make a function block. Call it IR read direction. Give it 2 parameters. First one is the channel, which is the port number where the IR Seeker is plugged into the hub. Second parameter is reduction factor. This parameter handles the difference for how the color sensor attribute values are represented on different Spike app versions. On Spike app 3 or newer, we will assign it a reduction factor of 4. For Spike app 2, we will give it a 1. In our main program, we will start with a forever loop. Now, we will program our IR read direction block. We will set the direction variable to the value of the color sensor reflect attribute value divided by 4 because we are using Spike app 3. We will round the value so that it is a single-digit integer, ready to be displayed. Actually, instead of using the 4 here, we will divide the reflect value by the reduction factor parameter which is passed in from the caller. This completes our IR read direction function block. Going back to our main program. Inside the loop, we will call our IR read direction block with port C and a reduction factor of 4. Again, the reduction factor is set to 4 because we are on Spike app 3. You should set it to 1 if you use Spike app 2. As the direction variable is set after call the IR read direction block inside our forever loop, we can display it on the LED light matrix. And this completes the programming our entire program. Now, let's do some testing. As we slowly move the IR ball around the front of the IR Seeker, observe how it detects each of the 9 directions precisely and reliably. This is the power of Quick Easy IR Seeker. For those of you who uses Python, here's the program in Spike app 3 with the exact same logic. The current program only uses the direction value from IR Seeker. We will now modify our program and use the signal strength value from IR Seeker to set the brightness of the LED pixels. The intended behavior is that the LED pixels should get brighter as the IR ball moves closer. First, we will add a new variable, strength. In our IR read direction block, we will add a call to read the signal strength value from the color sensor RGB red attribute. Note that in order to read the raw RGB values, you must have the More Sensors extension turned on. To set the value for the new variable, we copy the round block from the line above, and we replace the reflected light block with the raw red value block. Make sure the correct port number is set. In the main forever loop, after calling the IR read direction block, we will call set pixel brightness with the strength value. Because the strength value ranges from 0 to 255, we need to scale the maximum value down closer to 100, therefore we will divide the strength by 2. And this completes all the program changes. Let's test our new program. As we move the IR ball around, observe how the LED gets brighter when the IR ball is close. It gets dimmer when the IR ball is farther away. For those of you who uses Python, here's the program in SpikeUp 3 with the exact same logic. In summary, we have learned the general concepts of how Quick Easy IR Seeker works, the procedure involved in setting up the IR Seeker hardware with SpikePrime, and how to access the data returned by IR Seeker using word blocks and Python. In the next lesson, we will show you how to use two IR Seekers to detect the IR ball with full 360-degree coverage.